Hi students, today I am going to explain molecular orbital configuration of some homonuclear diatomic molecules. In the last video I explained linear combination of atomic orbitals, how the molecular orbitals are formed. Let's see the examples how the molecular orbitals are formed in some diatomic molecules, and homonuclear means same molecules forming diatomic molecules like hydrogen, helium, beryllium, boron, nitrogen, oxygen, etc. So first hydrogen molecule H2, its atomic number is 1. So electronic configuration is 1s1. So combining of two 1s atoms to form bonding molecular orbital and anti-bonding molecular orbital. So one electron is shared between two atoms to form sigma 1s and sigma star 1s. Sigma s is bonding molecular orbital and this is anti-bonding molecular orbital. So now we have to calculate what is bond order. It will give how much bonds are formed. Bond order is equal to half into bonding molecular orbital minus anti-bonding molecular orbital. Here two are there. So 2 electrons minus nothing is there, so 0. So half into 2 minus 0, that is equal to 1. So single bond is formed between hydrogen. So bond order is equal to remember this, half into number of electrons of anti-bonding minus bonding molecular orbitals. Then when we see here helium molecule, He2 molecule, so its electronic configuration is 1s2 because its atomic number is 2. So 1s2 and 1s2, here two helium molecules combined to form bonding and anti-bonding molecular orbitals sigma 1s and sigma star 1s. So bond order is equal to half into number of electrons in anti-bonding minus bonding. So whatever is the number is coming, that much bonds are formed. So here 1 is coming, so single bond is formed. If it is 0, then that molecule will not exist. So let's see next helium molecule. Two helium molecules combined together to form He2 molecule, and its electronic configuration of helium is 1s2. So 1s2 combined to form sigma 1s bonding molecular orbital and anti-bonding molecular orbital. And if we calculate the bond order, half into, here 2 electrons are there, 1 2, here also 2 electrons, 1 2. So 2 minus 2, that is half into 2 minus 2, anything multiplied with 0 is 0. So if the bond order is 0, I already told that molecule will not exist. So helium 2 molecule will not exist. Then when we see helium molecule ion, so when helium molecule ion, so it will exist or not, let's see. Here same helium atom with helium plus ion, one helium atom with one helium plus ion combined together. Helium atom will have 2 electrons, but it have only 1 electron, because how it will get positive charge when it donate 1 electron. So only 1 electron is remaining here. So where it 2 combines to form bonding molecular orbital, anti-bonding molecular orbital. So it is 2 bonding molecular orbital 2, anti-bonding molecular orbital 1. So half into bond order is equal to half into 2 minus 1, half into 1, 2 minus 1 is 1. So we'll get half. What is half? Half bond will not be formed. If it forms also, it is very less stable. So helium 2 plus is less stable than hydrogen molecule. Then next is lithium 2. Let's see. Its atomic number is 3. As we know, electronic configuration is 1s2, 2s1. So 1s2, 2s1 we wrote. So 1s2 of one lithium reacts with 1s2 of another helium atom to form the bonding and anti-bonding molecular orbitals, and 2s1 of one lithium with 2s1 of other lithium atom combined together. So when because it is inner shell, we'll calculate the bond order for this shell. So 2 minus 0. So half into 2 minus 0, that is nothing but half into 2. So 2 to cancel 1. So we'll get 1, means single bond is formed. Lithium single bond is formed. So it exists. Next is beryllium 2. So as that atomic number is 4. So electronic configuration is 1s2, 2s2. So let's see how it is formed. So 1s2 and 2s2. So 1s2, it will react with one more 1s1 react with one more 1s of beryllium to form bonding and anti-bonding molecular orbitals. 2s also both will react to form bonding and anti-bonding molecular orbitals. Here we can take the in outermost. So 2 minus 2. So half into 2 minus 2 bond order is 0. So when the bond order is 0, it will not exist. So like this beryllium 2 molecule will not exist. Next is boron molecule. Let's see. So its electronic configuration is 5. So 1s2, 2s2, 2p1. So here 5 electrons. So 10 electrons together take part in the filling process. So 2s and 2p outer shells, these two are we are taking 2s2. So with 2s of another boron, here bonding and anti-bonding molecular orbitals are formed. Here 4, 1, 2, 3, 4, 1, 2 and 2p orbitals. It also forms single 2p orbital with single 2p orbital of another boron to form sigma 2p and sigma star 2p bonding and anti-bonding orbital, and also pi bond is also formed as we learnt in linear atomic combination of atomic orbitals. If pz reacts with pz, then there will be head-to-head overlap. Then the sigma bond is formed. If it is py or pz, then pi bonds are formed. So like this we do. We draw the diagram of pz and also px and py. So we will get a bond order is equal to half into 4. So 4 minus 2. So 2 will get 1 bond order. So one covalent bond is formed between this. Because 2s and 2p will not have so much of energy difference, there will be the mixing of orbitals. So we will take all these into consideration. So here we can get doubt here. Bonding and anti-bonding 2 minus 2 0. So and here 1 1 1 it combined, how the bond will be formed, you may get the doubt. And we also may get a doubt whether it is a paramagnetic or diamagnetic. So here because 2s and 2b will have less difference in their energies, these two mix up, so that we will get the bond order half is equal to bonding is 4 1 2 3 4 here, and anti-bonding is here 2, here is 0. So like this we will get. So here 1 2 3 4 1 2 in S, and in P 1 plus 1 2 here. So 4, and here it will be anti-bonding, nothing will be there. So 0 plus 2, here 2. So 2. So we will get like this. So it exists. Thank you.